Right, this is last year's papers. There were actually 2 questions last year which would have fitted in with your Unit 3 household electricity. Question 4 on paper 1 was about a plug, or the first part of it was about a plug. And it asked you just to label the letter of the wire which was connected to the live pin, the neutral pin and the earth pin. Now the easiest one probably is the earth pin, because you know it's stripy, it's yellow and green. So the earth pin is going to be B. You also know, you can't tell the difference between these two. The question paper as well wouldn't have been in colour, but you should know that your live wire is connected beside your fuse. So your live pin must be at C there, or your wire must be C. And then beside your neutral pin there's only one left, and that's A. You needed all 3 to be correct to get your 1 mark there. What names are given to the parts D and E? So D, of course, is the fuse. And E is another safety feature they always want to make sure that you know. And E is a cable grip. It has to hold the entire cable in place. If you have your 3 wires showing out here, then that means somebody could come along, pull out the plug, and those 3 wires which are connected into the 3 things, one of them could come loose. And in particular, if it was the earth wire came loose, you wouldn't know that there was anything wrong. You wouldn't have any clue that there was anything wrong with that. But you could get a very nasty shock, because there's no earth wire then connected to your appliance through your socket to the earth plate under the ground. And so you're in trouble then if you touch it. So that's why we have a cable grip. It holds the cable very safely in place, and there's no danger of, when you pull out the plug, that some of these 3 wires could come loose from their pins there. So E then is the cable grip. Alright, a washing machine is a metal frame. A fault occurs so that the live wire connected to the motor is detached and makes contact with the metal frame. Explain fully how the fuse and the earth wire in the plug above work together to prevent a person touching the frame from being electrocuted. So if I just drew out a metal frame here, if this was your live wire coming in and your neutral wire coming out, and it's connected like this here, and this is the metal body, and something happened that you have that live wire touching the metal frame. If a person comes along, touches that, they're going to feel a severe shock. However, with your metal, so that's live and that's neutral, if you have an earth wire connected here, then the current, instead of flowing through the person, will see a path of much less resistance than the person, and that's through the metal body of the frame and out through the earth wire, and that's what it will do. But in your live wire you also have a fuse. Because there's a large current flowing, the fuse is going to blow, and that will stop your appliance working altogether, but it will also make sure that the person touching it won't get a shock. So how do you write all that down to get yourself 4 marks? Well, if you just start with something about the fact that the current chooses to flow through a path of least resistance. I'm just going to write R for resistance there, and that's the earth wire. Now, given that it's got a path of least resistance, a very large current will flow, or larger than normal current flows. Okay? So then the current exceeds the fuse rating, so the current will be much larger than the fuse allows. So the fuse blows. And then the last part, the circuit is switched off. Now that question has come up a number of times, and it's hardly ever answered perfectly where people would get 4 marks. It would be worth your while learning that off. So current flows through the path of least resistance, which is earth wire. That means that a larger than normal current flows, so it's going to flow around the case and out here, and even if the person is touching it, the person has much more resistance Even if the person is touching it, they have much more resistance than the case, so it's going to go through the case and out through the earth wire. Then larger than normal current flows, much larger than the fuse blows, and the current circuit is switched off, and there's absolutely no danger to the person anymore. Part B is a cost of electricity question. Mrs. Henderson is investigating the use of electricity in her home. She reads her electricity meter at the end of the week and records her readings in the table. The difference between the reading at the end of week 2 and week 1 is the number of units used in week 2 and so on. Okay, so at the end of week 2 and the end of week 1 would be the number of units used in week 2 and so on. So, first question, complete the table by entering the numbers in the appropriate boxes. So you can see here along the top, all you're doing is adding on the number of units to get the next number here. So we'll just do this top one. First of all, you know there was 12,681 units had been used previously in week 5 there, and the units used during week 5 were 144. So you just add 144 onto this, and that gives you 12,825. And then to calculate the units used during week 3, all you have to do is take week 3 away from week 4, and that comes out at 157. What do the units in the above table measure? If you remember that kilowatt hours or units are a unit of energy. So it's kilowatts times hours, so that's power by time, that's energy. And that's the answer. Electricity costs 11 pence per unit. What's the cost of a kilowatt hour? That's really a trick question where they're just checking, do you understand that a kilowatt hour and a unit are the same thing? So the answer is 11 pence. And then calculate the cost of electricity in Mrs. Henderson's home in week 2. Now, it would be very easy to use the wrong number here. You could look at week 2 and look down and say, oh, that must be 127. But 127 is the number of units that are used between week 1 and week 2. So that's during week 1. So that means that we're looking for this number here, 129. So all you have to do then, just move this up a little bit, you have to multiply 129 units by 11 pence a unit. And that gives you 1,419 pence. We have to give our answer in pounds, so it's £14.19.